everybody, I'm going to talk about nitrile reduction with LAH in this video. So this is going to be a very similar mechanism to what we saw when we did the LAH reduction with carboxylic acids and with amides. So we're going to see a very similar situation here where the lithium aluminum hydride is not only going to act as a nucleophile, but it will also act as a Lewis acid once it's reacted once and given away a hydride. So if we think about the amide version of this LAH reduction, we see the oxygen go away and we end up adding two H's and getting an amine out the other end. So this is going to be a very similar process here where we're adding two H's. We don't obviously have an oxygen to work with to begin with, so it's going to turn into an amine as well. So nitriles are pretty much always going to go to a primary amine because you only have that carbon and you're adding two H's to it. So you're pretty much going to end up with a primary amine as your product every time, okay? So the mechanism here is going to be very similar to our other LAH mechanisms that we've done. So we start off with our LAH, the hydride. That hydride is going to go and attack the nitrile carbon. Okay, so we've added one H. That nitrogen is now negatively charged. Okay, so once I'm here, then that N- is going to be a good Lewis base for the ALH3 Lewis acid that I have generated. So remember, the aluminum is going to be has an empty p orbital in it, so it can hold 8 electrons. Right now it only has 6 when it's ALH3. So we're going to go coordinate that with the nitrogen. And the interesting thing is, once we've done that, now our aluminum is negative again. And so now we have another source of hydride. Okay, so now we can use this as our hydride source. And we can just come do an intramolecular reaction, move electrons up onto the nitrogen. And now I've ended up with my 2 additions of hydride. And then I'm ready to go into my water quench because I don't have anything else that I can do right now. I don't really even have a carbon, like any kind of double bond that I can work with anymore. So we're going to go right into the quench. You don't really need to worry about what exactly happens here, but as soon as you have that water, it's going to grab that. It's going to protonate your nitrogen. The aluminum is going to end up in the water layer, and then you're going to end up with your product in the organic layer. So we're going to protonate that amine twice. And we've got our 2 hydrides that we added on, okay? So you don't need to worry about knowing this mechanism. I only do it just because I know that some people really prefer to have the mechanism listed out. So here it is. Again, very, very similar to some of the mechanisms that we've seen previously with the carboxylic acids and the amides. Alrighty, so we have another way to make amines. So have fun with this one, and I will talk to y'all later.